Who is this? Chaitanya?
Yes, sir.
Good. So Chaitanya, what we completed in the last class? Did you remember? We completed about the matter, I think. Yes?
Yes, sir.
So we completed the matter and we discussed some important some questions also, I think. Yes? Yes or no? So classification of matter, we discussed this chapter. So this topic with this actually I think we have done, I think. So total. So today I have to start some new topic. Now I perfected these topics, what we completed. Okay, so shall I start the new chapter, new topic today?
Yes, sir.
Right. So today we are going to discuss about the elements first. Okay. So first we see the elements. Do you know total how many elements are known as on today? Yes. So total as on today we know that 118 elements. Okay, 118 elements. Okay. So these every element is different from other element. Every element is different from other element. Okay. So how they are different? They are different in physically and chemically. Okay. Physically means what, like appearance or something like this. Okay. Physically and chemically, how do they react? How their internal properties chemically they are different from each other. Okay. And the reason for the difference between the two elements is nothing but that is due to number of electrons or number of protons. Is this clear to you?
Yes, sir.
So here you see these elements. Okay, before going to the element, you know that atom is there, and atom actually it consists of three fundamental particles. Do you know that?
Yes, sir.
What are those fundamental particles?
Electrons, protons, and neutrons.
Very good. So there are three fundamental particles are there. In that, first one is electron. Okay, and the second one is protons, and the third one is called neutrons. Okay, so like this three fundamental particles are there, and these fundamental particles, if you go through about the charge and masses, then electron carries 1 unit of negative charge, so we can write -1. The charge, this is a charge. Okay, the charge is -1. Okay, proton carries +1, the charge is +1, 1 unit of positive charge, and neutrons are neutral, so neutral we represent with a 0. Is this clear? Then when we come to the mass of electron is negligible. Negligible means what? Very less. Okay, that one we don't consider. Others approximately we can write 1 by 1840 times of hydrogen or proton we can write there. Okay, so 1 by 1840 times of a proton. Okay, and proton is considered approximately 1 AMU. Nowadays we are writing as 1 U also. AMU stands for atomic mass unit and U stands for unified mass. Neutron also same, we write 1 AMU or 1 unified mass, but neutron's mass is very slightly greater than the proton's mass. Is this clear till here? Any doubt?
Yes, sir. Clear, sir.
If you want to take, you can take the screenshot of this one, or you can write. Writing is better instead of taking the screenshots.
Sir, I wrote, sir.
Very good. Okay, so now these elements, every element has one, means one number. Like how do you have a rule number? So similar in your class, similarly here every element is having some one number. That is called atomic number. What it is called?
Atomic number.
Do you know what is atomic number?
Yes, sir.
What is that atomic?
The number of electrons in an element, sir.
Yeah, so every element has one number which is called as the atomic number. Okay, atomic number. Okay, and the definition of atomic number is, okay, the number of protons. Okay, the number of protons. The number of protons in the nucleus of an atom. In the nucleus, okay, of an atom is called the atomic number. In one atom, generally you know that atoms like spherical in shape. How they are? Spherical in shape. In that sphere, there is one small central region will be there. At the center of the atom, there is one small region is there. That small region is called nucleus. What it's called? Nucleus. In that nucleus, protons and neutrons are present. Okay, these protons and neutrons. Okay, these protons and neutrons are present in the nucleus. They are present in the nucleus. So that's what they are called, nucleons. Okay, protons and neutrons collectively called as the nucleons because they are present in the nucleus. And what about the electrons? Electrons revolve. Electrons, what they do? They revolve. Okay, around the nucleus. Around the nucleus they revolve. Okay, around the nucleus. Okay, so like this is the, okay, nucleus of atom, and electrons will be revolving like this in various orbits of an atom. Okay, this all we discuss in the next coming classes, but as of now you remember that out of three fundamental particles, protons and neutrons are present in the nucleus and electrons are revolving around the nucleus. Is this clear? Now atomic number means what? The number of protons in the nucleus. So how many protons are there in the nucleus at the center of atom? That number is called atomic number. Okay, and generally it is denoted by Z. It is denoted, okay, denoted by Z. Okay, letter Z we write to represent this one. Okay, and the most important point to what is that is, you said no, atomic number means what? The number of electrons. You said yes, that is also correct. So in a neutral atom, the number of protons, okay, the number of protons, sorry, can it? Okay, the number of protons is equal to number of electrons, is equal to number of electrons. So that's what okay, in a neutral atom. So that's what we can call atomic number is nothing but a number of electrons also, but you should not say that. You have to say, when anyone asks you to what is the atomic number, you have to say number of protons only. Okay, why? Because protons are present in the nucleus, they cannot move, okay, anywhere. So but electrons can move from one atom to other atom. Is this clear? So atomic number. So atomic number means what? Number of protons in the nucleus of an atom, and it is denoted by Z. And in a neutral atom, the number of protons is equal to number of electrons. Okay? So note down.
Yes, sir.
Now this atomic number is done. Now let's go to the mass number also, or atomic mass, anything we can say. The difference will be there little bit. I'll explain in the later classes, because now we are in 7th only, no? So when you're going to the depth of the topic, depth of the subject, I'll explain you one by one. Okay, reveal this one. So now, as of now, we take the mass number, okay. So mass number is nothing but it is like a atomic mass. Okay, atomic mass means the mass of an atom. Okay, so the mass of an atom. So but in the mass number, how can you define is, we can define this as the sum of protons and neutrons in an atom. Okay, so what is mean by the sum? SUM? Yes, Chaitanya, what is the sum meaning? SUM, sum means what? Addition. So here what we are doing is, we are adding the sum of the protons and neutrons in an atom. How many protons and how many neutrons? This we take and we add the total number. That becomes a mass number. That becomes what? A mass number. And the mass number is denoted by A. Okay. Okay, so mass number is denoted by A. So here what we can write, the mass number is denoted by A. So I am writing like mass number is A is equal to the sum means what? Addition. Okay, sum of the protons and neutrons. So number of protons and number of neutrons, when I add, I will get the mass number. So A is equal to P plus N. Is this clear to you? Now you see now, but A is equal to P, but in the previous slide, P means what? Number of protons, no? Number of protons is called atomic number and it is denoted by Z. So that's what I do in the place of P. P means nothing but a number of protons, but number of protons is called as atomic number, and atomic number is denoted by the Z. So that's what, instead of writing P, I can write the Z here. Okay, can I write? So this is the formula of A is equal to Z plus N, where A is the mass number, Z is the atomic number, N is the number of neutrons, and Z is atomic number means what? The number of protons or number of electrons also you can see. Okay, and if I want to find the number of neutrons in any atom, if I want to find in any atom, so what is the formula then? N is equal to A minus Z. Yes or no? Because the A is equal to Z plus N. I want N keeping there only, Z I am bringing other side. So you know already, I think you might have studied the mathematics, when you move, okay, from one side to other side, then what happens? Its symbol, sign will be changes. Yes or no? So therefore, this plus Z becomes minus Z. So N is equal to A minus Z. This is very, very important. Now I'm going to give some work to you. So that's what, it's very important. So now note down this one. Done? Right. Now I am going to explain you now. So first 20 elements. Do you know first 20 elements?
Yes, sir.
What are those? Come on, you say.
Yes, sir. Hydrogen. Helium. Lithium. Beryllium. Boron. Carbon. Silicon.
After carbon, nitrogen.
Fluorine, neon, sodium,
silicon,
phosphorus, sulfur,
chlorine.
argon, potassium, calcium.
Very good. Very good, Chaitanya. Very good. So these are the 20 elements. Okay. Now today I am going to explain you their atomic number and their mass numbers and how many protons, how many electrons, how many neutrons to write. Okay, are present in every atom. Okay, that is very important. So we discuss now. So for this, what we do? Okay, you make some columns here. First you write element, first you write here element, then you write the symbol, then you write the atomic number, that is Z. Just I am writing Z. Z means what? Atomic number. Then you write the mass number. Then you write the number of protons. Okay, so number of protons. Then you write the number of electrons. Then you write the number of neutrons. Okay, so like this you make columns. Like this. So now here you know the 20 elements, so you write the 20 elements one by one. So first I'll write few elements here. Okay, so I'll write a few elements here. First hydrogen, next helium, lithium, beryllium, boron, carbon. Till I will write this one. And the symbol of hydrogen is, do you know? You write 20 elements, and today I will give all atomic numbers, you know, first 20, but mass numbers also I will give. So now see now you have to know every element consists of how many electrons, how many protons and how many neutrons. So see a number of protons. How many protons are present in the hydrogen? 1, because atomic number is 1. So write to 1. How many electrons are present in the hydrogen? 1 only, because how many protons are there? Same number of electrons will be there. I said, you know, so 1. So write 1. How many neutrons are present now?
1.
Why 1? So see here in the previous slide, number of neutrons, how can you find the formula?
A minus Z.
Then what is A here and what is Z here?
Mass number, sir.
So what is the value of hydrogen here? A means mass number 1 and atomic number 1.
-1, 0, sir.
So 0. Okay. Now for helium you say now.
The helium, 2 protons, 2 neutrons and 2 electrons, sir.
Very good. Now lithium.
Sir, lithium, 2 protons and 2.
Why 2 protons? 3.
3 electrons and 3 protons, sir. Neutrons is
4 because A minus Z. Okay, you have to subtract this number from this number. So 7 minus 3 is 4. Good. Now for beryllium.
Sir, beryllium elements and electrons and protons 4, sir. Neutrons 5, sir.
Very good. Next boron.
Sir, borons, electrons, protons 5. Neutrons is 6.
Good. Carbon.
Sir, carbon, electrons and protons 6, sir. Neutrons also 6.
Neutrons also 6. Okay. Now what I do is I will say the atomic number and mass number for first 20 elements. Okay. You note down, and that remaining part, electrons, protons, neutrons part, you complete okay, as a homework. Is this clear? So I will say only atomic number and mass numbers I will write. Okay. So this I am done. Okay. So now in the next onwards, what I am going to do? I am going to do write only atomic numbers and mass numbers. Okay. So there carbon, till carbon we are done. So carbon after nitrogen, oxygen, fluorine, neon, sodium. Okay, so these symbols, you know, nitrogen in N, oxygen O, fluorine F, neon Ne, sodium Na. Next atomic number Z, that is 7, 8, 9, 10, 11. Next mass number nitrogen 14, oxygen 16, fluorine 19, neon 20, sodium 23. Only this I am writing. Remaining part you have to complete. So this is number of protons, electrons and neutrons. These three you have to complete. I am not writing this one, later. You take that as a homework and you complete. So first only this part you write. Done till here, 23.
Yes, sir.
Oh, very good, very fast you are, Chaitanya. Okay, so sodium done. Now next is magnesium, aluminium, silicon, phosphorus, sulfur. And their atomic numbers are symbols: magnesium Mg, aluminium Al, silicon Si, phosphorus P, sulfur S. Their atomic numbers now. Atomic number means Z. Z is 12, 13, 14, 15, 16. Next mass numbers. Mass number 24, 27, sorry 29, this is 29, 31, 32. Remaining part you have to complete. Number of protons, electrons, neutrons you have to complete. Done? Okay, till sulfur we have done. Now last after sulfur. Sulfur after chlorine. Chlorine, argon, potassium and calcium. Okay, first 20 elements are enough. Okay, so chlorine is Cl, argon is Ar, potassium is K, calcium is a Cl. So these are the symbols. Okay, now next is atomic number Z, that is 17, 18, 19, 20. Now next mass number for chlorine is 35.5. Okay, and argon is 40, potassium 39, and this is 40. Okay, and remaining part you have to complete. Done? Right. So this up to 20 elements, symbols, atomic numbers and mass numbers you have to learn. Right? So that you will come to know how many protons, how many electrons, how many neutrons will be there in any atom. Okay. Now after this, the next topic what I explained to you is the valency. Do you know what is the valency? Okay. Yeah, okay. So instead of that we say simple definition first, then we go into depth. Okay. So as of you are in 7th class, we discuss only about the valency. We are not going to discuss about the charges and so on. Okay. So valency, okay, valency can be defined as the combining capacity of an atom. The combining capacity of an atom. The combining capacity of an atom is called valency. Okay, so this is a simple definition. Okay, and so here it is not giving any information, just it is giving like combining capacity. One element is combining with how many elements, okay, that much it's giving, but it's not giving, okay, it is more information. So for that we have one more definition also. Okay, so one more definition of valency is nothing but the capacity of an atom, the capacity of an atom to combine with the number of hydrogen atoms. Very important, this one. Hydrogen atom. Okay, this is very important. Or twice the number of oxygen atoms is called valency. Right. So now note down this one. The combining capacity of an atom is called valency, or the capacity of an atom to combine with the number of hydrogen atoms, or twice the number of, twice the number of oxygen atom is called valency. I'll explain you now about this one. So once go through this one. Write this one. Done? Now I'll explain this. Okay. So here, for example, you see what is the formula of water? H2O. So H2O is the formula of water. So in water molecule, each oxygen is combining with how many hydrogen? In water, water molecule, oxygen is combining with 2 hydrogen atoms. Okay, 2 hydrogen atoms. Yes or no? So hence the valency of oxygen is 2. That's all. Is this clear to you?
Yes, sir.
That's called combining capacity. So in water molecule, oxygen is combining with the 2 hydrogen atoms. So the valency of oxygen is 2. Now, similarly, do you know what is the formula of ammonia? Do you know formula of ammonia? Ammonia formula is NH3. What is the formula of ammonia? NH3. So in the ammonia, nitrogen is combining with how many hydrogens? 3. So therefore, the valency of nitrogen is 3. Is it clear to you? What is valency? Okay? Now I'll ask the question now. Let us take the carbon dioxide. What is the formula of carbon dioxide? Chaitanya, are you there? Chaitanya, are you there?
Yes, sir.
So now, what is the formula of carbon dioxide?
CO2.
So here now what is the valency of carbon? What is the valency of carbon?
2, sir.
Why? So here valency of carbon is 4. Valency of carbon is 4. So you may ask me, why sir here carbon is combined with only 2 oxygens, then why you written 4? Okay, but I give the definition here. See here, the capacity of atom to combine with the number of hydrogen atoms. If number of hydrogen atoms is there, how many hydrogens with it's combining, that is a valency. But if it is combining with oxygen, then what you have to take here? Twice. What do you have to take? Twice the number of oxygen atoms. Means if it is combining with 1 oxygen, then you have to take 1 into 2. So 2 is the valency. If element is combining with 2 oxygens, then the 2 2s are 4. so that becomes double. Okay, so when you consider the oxygen, okay, how many oxygen atoms it's combining, then its valency becomes twice of the number of oxygen atoms. If you are considering hydrogen, then same number. With how many hydrogens it's combining, that is its valency. But for oxygen, with how many oxygens it's combining, that twice of the number of oxygen is considered as the valency of that element. Is this clear to you? Yes? So now this is most important. So if it is combining with hydrogen atoms, same number you can take. But if it is combining with oxygen, you have to take how many oxygens are there? For that you have to make it double. So that is the valency of that element. Okay. So here you can write this example now. Carbon dioxide. Okay. Carbon valency is 4. Why? Because carbon is combining with 2 oxygens and every oxygen valency is 2, so 2 2s are 4. Is this clear to you?
Yes, sir.
Sure. So with this we stop today, and then tomorrow I am going to give the valencies of first 20 elements, and then I am also going to explain you tomorrow, means in the next class, how to write the formulas of the compounds. Okay?
Okay, sir.
Right. Okay. Okay then.